Okay, welcome back to the channel. It's always a pleasure to have you here again, and we're here to learn mathematics. And fortunately, today we are going into a new topic. We've been treating quadratic equations for some time now, and I believe if you've watched those videos, you must have learned a lot about handling quadratic equations. All right, so welcome back again. I am Pendulum. I'm your tutor on this channel, and if you are new, I would like you to support the channel by just subscribing and turning on notifications so that you can be informed when next we post a video. Okay, welcome. As you watch, please don't forget to like this video, drop your comments so that I know what you think about it, and also share this video with your friends, fellow students, and your children, your words, who you think would benefit from it. All right, so let's get right into today's video. We are going into number-based systems. Okay, I've decided to go to the beginning of senior secondary school mathematics. So let's look at number-based systems. And we said a number-base. Okay, sorry, this is a mistake. A number base. A number base is simply a system of counting. That's the simple definition of a number base. It's a system of counting. So we always count in number bases. The common number base or system we use to count is the decimal, and that's the third one here. Okay, so let me just explain them. We have some common number base. Almost every number is a base. So we have base 2, we have base 3, we have base 4, we have base 5. Every number has its base, its counting system, but there are some that are common which have been given names to identify it. So first of all, we have the binary number system. Binary. This is a number system that your electronics and your computers use. And binaries is counting in base 2. So when you see binary, it means base 2. Okay? And it has just 2 digits. It is base 2, so it has only 2 digits, 0 and 1. You should note this, that the highest digit of any base is always one number less than that base. Very important. The highest digit of any base that you're working in is always one number less than that base. So if we apply that here, we say binary is base 2. The highest digit in base 2 will be one number less than 2, which is what? 1. 1 is one number less than 2. And that's why we have only 2 digits in binary, 0 and what? 1. So there are two things you should note here. The base you're working in determines the number of digits you have. First thing to note, the base you're working in determines the number of digits. So if you're working in base 2 binary, you have 2 digits. If you're working in base 5, you have 5 digits. If you're working in base 10, you have 10 digits. If you're working in base 16, you have 16 digits. And the highest digit will always be one number less than that base. So any base you're working in, the highest digit in that base would always be one number less than that base. So binary is 0 and 1. 1 is one number less than 2. Remember, binary is base 2. Then we also have octal. That's the next one that has a name. Octal is base 8, counting in base 8. Okay, and since it's base 8, it's going to have how many digits? Yes, 8 digits, just like I explained. This is base 8 is going to have 8 digits, and the highest digit or the highest number in base 8 or in octal is going to be one number less than 8, which means the highest digit is going to be what? 7. So octal system is from 0 to 7. The numbers in octal number base system is from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. That is 8 digits if you count from 0 to 7. 8 digits, just like I said, and the highest digit is what? 7. So in octal system, there is no number 8, there's no number 9, there's no number 10. Alright, the only digits you can find in octa are digits from 0 to 7 or a combination of these digits. But you can't find any digit, any number that has 8 or 9. Okay, and then in binary or as well, we can only have 0 and 1. So any binary number must always be a combination of 0 and 1. You can't find 2 or 3 or 4 in the binary system. Then we have the decimal system or the denary system. Like I said, the decimal system is the common base we use to count every day. Alright, so this is the base 10. Decimal is base 10, the common base we use to count every day. Since it's base 10, it has 10 digits. 10 digits, and the highest digit here is one number less than the base, which is 10. One number less than 10 is 9. So our digits for decimal is from 0 to 9. And if you count it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 digits. Okay, 10 digits from 0 to 9. The highest digit is 1 less than the base, which is 10. This is your number, your normal system. So if you're counting your 1, 2, 3, you count in base 10. When you get to 9, that's the highest digit. You now have to go back to 1 and 0, 1 and 1, 1 and 2. If you get to 1, 9, you now go back to 2. Okay, that's how it works. So you have the hexadecimal. This is base 16, counting in base 16. That's the hexadecimal system. Okay, your colors are given or represented by hexadecimal numbers and hexadecimal codes. If you've ever seen colors in your electronics or in physics, they are represented by, or even if you're a graphic designer or you've come across color codes, they are always in hexadecimal. Hexadecimal is the only system that has letters in it. The only number system that has letters. So hexadecimal is base 16. That means it's going to have 16 digits. Please remember, base 16 means it's going to have 16 digits. And then the highest digit is going to be one number less than 16. So our highest digit is 15. Hexadecimal has digits from 0 to 15. Okay, from 0 to 15. But like I said, this one has numbers. If you're writing hexadecimal, when you get to 9, you don't write 10, 11, 12, 13, 14, 15. No. From 10, you represent it with the number A. Okay, so 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So for the hexadecimal system, you have 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you now have A, B, C, D, E, F. That's 0 to 15. So take note of that. This is the only one that has letters, hexadecimal base 16. And the letters start from 10, A, to F, 15. Alright, this is quite simple. The other bases do not have names, but they are still very valid. So you will still see base 5, base 6, base 3, base 7. They are all valid. They are all useful number based systems. Okay. Now, if you've understood this, the next thing we'll look at, I want to keep this video short. So the next thing we'll look at is how to conversion of number bases. Conversion of number bases, how to move or convert numbers from one number base to another. So let's start with converting numbers from base 10 to other bases. From base 10 to other bases. Now note something. I told you that base 10 is the common base or the normal base. If a number is written and no base is attached, a base is written as a small number at the bottom of the normal number. What I mean is, if I write 30 like this is 30 in base 4. Okay, so a base is written as a subscript, a smaller number below the main number. I can write 20 in base 3. This is how you write your number bases. So take note of that. And the point I was trying to make here is that if you see a number not attached with any base, it is automatically assumed that that number is in base 10. Okay, so if I put 10 here, it shows you clearly that it's base 10. If I don't put 10, you still assume that it's base 10 as long as another base is not there. Why? Base 10 or decimal is the common or natural base of numbers. Take note of that as well. Alright, so if we are converting from base 10 to other bases, we do this by division. We use what? Division method. So let's look at these examples, and this should be okay to help you understand this properly. Number basis is quite simple, and I'm sure is many people can do it, but I've still seen people who struggle with it. So that's why I decided to choose this topic. We should be done in no time at all, and we'll move on to another topic. So we're asked to convert these numbers to the indicated base. Remember, all these numbers are in base 10. So we have to convert them to the bases indicated here. So number one, we are asked to convert 77 using base 10 to base 5. Okay, we need to clean this side, but let's solve here first. Now I said we use division to do this. We use division, long division. So we are going to divide. Now, because we are converting to base 5, we are going to divide this 77 by 5. And as you divide, you write down your remainders. Remember that. As you divide, you write down your remainders. So if you are not so good with division here, you can use a calculator to help yourself. 77 divided by 5 is going to give you 15 remainder 2, because 15 times 5 is 75. So 77 divided by 5 is 15 remainder 2. Okay, you can confirm with your calculator. Then we are done with this step. We'll divide again by 5. We'll keep dividing by 5 till we get 0. We'll keep dividing by the base you are converting to till you get 0. 15 divided by 5 is 3. In this case, there's no remainder, so we write remainder 0. Please remember to write your remainders. Now we'll divide again by 5. 3 divided by 5 will not be divisible, right? It cannot give you a whole number. So this is going to be 0 remainder 3, because 5 cannot divide 3 without a remainder. Because 5 cannot divide 3 and give you a whole number. So we have 0 here, remainder 3. Okay, so at this point, to get your answer, you read this from down up. You read the answer from down up. So the answer is not 203, it is 302. So what this tells us is that 77, let's say in base 10, is equal to 302 in base 5. It's as simple as this. Okay, so this is the process. Any number you're converting from base 10 to another base, you divide that number by the base you're converting to, and you keep doing this division repeatedly, writing out your remainders. If it divides it completely, you remainder 0. If there's a remainder if it doesn't divide it completely, you write down the remainder. You keep doing it until you get to 0. Okay, when this cannot divide again, when the number cannot divide again, then you get 0 remainder whatever is remaining. Then remember to take your answer from down up. Very important. Take your answer from down up. Alright, so let's look at other examples. Okay, so for the second one, number 2, we're asked to convert 834 in base 10 to base 6. 834 to base 6. 834 in base 10 to base 6. So same way, division, 864. Now we are converting to base 6. So we are going to divide, 834, not 864. 834, right? So now we are going to divide it by 6, by the base you are converting to. So let's divide by 6. Okay. Now if you divide 834 by 6, you should get 6 into 8 is 1, remainder 2. If you don't have a calculator, this is how you divide. 6 into 8 is 1, remainder 2. 6 into 23. 6 into 23 is 3, remainder 5. Right? Yes. Then 6 into 54 will be 9. Yes, 9. So 9, remainder 0. Okay, because 6 times 9 is 54. So if 6 divide this, you'll get this. Remember, this is how I did it in case you struggle with division. 6 into 8 is 1. It will remain 2. Okay, remember 2. You put the 2 here, and that is 6 into 23. That 2 and 3, that's 23. And 6 into 23 will give you 3. 6 times 3 is 18. And then you have a remainder of 5. Okay, then you put the 5 in front of 4, and then it says 6 into 54. That will give you 9. No remainder. Then we'll divide again by 6. We repeat the same process. Now in this case, 6 cannot divide 1. Okay, 6 cannot divide 1. So you say 13 divided by 6. Please take note, in the first one, I use 8 only, the first number, because 8 can be divided by 6. But in this case, 1 cannot be divided by 6, so I have to use the first two numbers. 13 divided by 6 is 2, remainder 1. That's 12, right? Remainder 1. Then 19, this 1 and 9, divided by 6 is 3, remainder 1. Okay? You can confirm all this with a calculator if you have a calculator. I'm doing it, should I say manually, so that you can understand and flow with me. We divide by 6 again. 23 divided by 6 is 3, remainder 5. Okay, 18, so 3 remainder 5. Divide by 6 again. Remember, you must get down to 0. Now 6 cannot divide 3 and give you a whole number, so we have 0 remainder 3. Now once you get to 0, you are at the end. You take your answer from down to up. So therefore 834 in base 10 is equal to 3510 in base 6. This is your answer. So you can see that these are quite simple. These are quite simple. Okay, so now I believe this is well understood. I think I will leave this last one for you as an assignment. Follow the same process. Okay, but before that, let me do 3 and 4. Now this one is a decimal, this one is a fraction. You have to convert them. They are in base 10, convert them to binary base 2 and octal base 8. The process is the same, division. The only thing now is that we are going to have multiple steps because we have fraction and or decimal. We are going to have multiple steps. So let me clean the board so that okay, so please, this number base is quite simple. It's quite simple. If you understand the process, it's very, very simple. Alright, so let's do the third one. That's number 3. We have to convert 259.75 is in base 10 to binary. Binary is base 2, remember. So the same way we are going to divide. Now, before then, how do you solve in this case where you have a binary? Sorry, where you have a decimal number, that's this 0.75. How do you resolve it? Now you break it into 2. First of all, remember this is like saying 259. Now this 0.75 is a decimal. If you remember your primary school mathematics, you can convert decimal to fraction. This is the whole number part. Now 0.75 means 75 over, this point is 1, then this is 2 zeros, 75 over 100. I hope you still remember your decimal fractions. I cannot go back to start doing that. That's primary school mathematics. But if you're converting from decimal to fraction, the numerator, that's the number after, the number after the decimal point is your numerator. That's what is going to be on top. Then over, the decimal point is 1. You count the digits after the decimal point and represent them by 0. So this is it. If I reduce this fraction to its lowest term, I'm going to have 259. If I divide 75 by 25, I have 3. If I divide 100 by 25, I have 4. So I think that's the lowest form. So I've converted this from decimal to fraction. Now what am I going to do? Since I'm asked to convert to binary, I will break it into 2. I will convert this whole number part to binary, and then convert this decimal part to binary on its own. So let's convert the whole number part first. Convert 259 to binary first of all. Okay, so let's do this one first. So we have 259. Now binary is base 2, so it's going to be a long division. Division will be lengthy. Now 2 into 2, 1. 2 divide 5 is 2, remainder 1. 2 divide 19 is 8, remainder 1. We'll go again, divide by 2 again. Remember binary base 2. 2 will not divide 1, so we'll say 2 into 12, that's 6. 2 into 8, 4. No remainder, remainder 0. Okay, we'll go again. 2 into 6, 3. 2 into 4, 2. Remainder 0. We go again. 2 into 3 is 1, remainder 1. 2 into 12, 6. No remainder. 2 into 6, 8. No remainder. 2 into 8, 4. No remainder. 2 into 4, 2. No remainder. 2 into 2, 1. No remainder. And then finally 2 into 1. 2 cannot divide 1 without a remainder, without getting fractions. So 0, remainder 1. Please remember, keep going until you get to 0. Then you take this from down to up. Okay, so this whole number part 259 in base 10 is 100000001. So 1, how many zeros? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 1 in base 2. Okay, so that's for the whole number conversion. Then we are still going to convert 3 over 4 to what? Binary. Now how do? We convert 3 to binary, we convert 4 to binary. So converting 3 over 4 to binary. Now we'll convert 3 to binary, we'll convert 4 to binary. So to convert 3, we'll divide by 2. Simple. 2 divided by 2 is 1, remainder 1. Then 2 divide 1. Again, you cannot divide it without giving you a fraction. So we have 0, remainder 1. Take it from down to up. This means that 3 in base 10 is 11 in base 2. And then to convert 4, we use 4 divided by 2 again. 2 into 4 is 2, remainder 0. 2 into 2 is 1, remainder 0. 2 into 1, 0, remainder 1. Okay, so 4 in base 10 is 100 in base 2. Now this is a conversion you should know. Okay, 3 in base 10 is 11 in binary. 4 in base 10 is 100 in binary. But I just did it so that you see the process in case you have other numbers that you don't automatically know their equivalent values. This is the same thing you do. Convert the whole number part to whatever base you're asked to convert it to. Then for the fractional part, you convert the top to the base, convert the numerator to the base you're asked to convert to. You convert the denominator to the base you're asked to convert to. Alright? And then since you've converted these two, that means that 3 over 4 in base 10 should be the same thing as 3 is 11 and 4 is 100 in base 2. I mean, right? It makes sense now. If 3 over 4 in base 10 should be 11 over 100 in base 2, because 3 is 11 and 4 is 100. Okay? But you don't leave it like this. Why? Your question was in decimal, so you need to change this to decimal, which is quite simple. If you divide 11 over 100, this is in fraction. If you change it to decimal, well, you know that if you divide any number by 100, what it simply means is you move your decimal point 2 times backward. If you divide by 10, you move your decimal point once backward. If you divide by 1000, you move your decimal point 3 times backward. So if our decimal point is here, remember this is 11, so decimal point is here. We are dividing by 100, we are moving it 2 times backward. That's 1, 2. So this should give me 0.11 if I'm writing it in decimal. Okay? Like I said, from here, take your decimal 2 times backward. 2 times backward. Okay? If you convert this to fraction, this is 11 over 100. So we are not wrong. So if we've gotten this part, all we need to do is to say that, therefore, 259.75 in base 10 will be equal to, now that's the whole number part, 1,000,000,001. Okay? 0.11 in base 2. I hope you understood what I did. This part should not be difficult. Just convert the whole number part by dividing. Then for the fractional part, convert this one to base 2. The numerator, that's this. Convert the denominator to base 2, that's this. And then you have this over this. Then you just turn it into decimal. 11 divided by 100 is 0.11. Then your final answer is a combination of this whole number part and this fractional part. It's as simple as that. Okay, so let me do this one. Let me do this last one. Now for your assignment, I'll leave this last one for you. I'll do that last one, but this is your assignment, so please write it down and try it. Convert these numbers. So I've already given you one. Number one, 52 to base 3. Do this conversion for me, and then do this one as well. 121 point 25 okay, convert it to base let's use base 7. Alright, so try these two as the assignment. This is 121.250. Okay, 121.250. 52 to base 3, 121.250 to base 7. Try these two as the assignment while I solve this number 4, and then we'll call it a day. So where do I clean? Do I clean the question? Okay. Okay. So number 4, we have to convert 78 5/8 to base 8. That's octal. Octal is base 8. So I think we can clean here. Okay, so let's round up. The solution, same thing. This is already a fraction, so we just divide it into 2. We'll convert the whole number part, and now then we'll convert the fractional part one by one. So first of all, we have 78. We are converting to octal, base 8, so we divide it by 8. Okay, so 78 divided by 8 should give you 9, remainder 6. Yes. 9 divided by 8 is 1, remainder 1. Then 1 divided by 8, of course, you cannot divide without giving you a fraction. So it's going to be 0, remainder 1. Take it from down up. That means that 78 in base 10 is 116 in base 8. So we are done with the whole number part. Now let's look at the fractional part. So we have to also convert. Okay, this first part, remember, we converted 78 to octal. Don't forget that. That's what we did here. We converted 7. So now we are going to convert the fractional part, 5/8 to octal. And like I said, you do it one by one. So you convert 5, you convert 8. So you're converting 5. Now, before I do this, I can tell you that if you are converting 5 in base 10 to octal, your answer is still going to be 5. Why? Octal has 8 digits, and the digits are from 0 to 7, like I showed you when I started. So all the digits from 0 to 7 have the same value. They are not going to change because 5 is a number in octal system. So the value remains the same. But let's try it out. If you want to convert 5 to base 8, 5 divided by 8, obviously 8 cannot divide 5 without it being a fraction. So this will just give you 0, remainder 5. If you take your answer, you will see that 5 in base 10 is equal to 5 in base 8. Just like I explained. Why? Because 5 is a number both in base 8 and in base 10. You see that the essence of this conversion is to bring a number in one particular base to another base. A number that is outside the digits of a particular base, you want to bring it within the digits of that base. So for example, 78 in base 10 is 78 is not a number in base 10. Sorry, 78 is not a number in octal. So by the time you convert it to octal, it will be 116, because when you're counting in octal, you're going to skip 8, 9. You're going to skip 18 and 19. You're going to skip 28 and 29. You're going to skip 38 and 39. You're going to skip 48 and 49, 58 and 59, 68 and 69, 78, 79. Okay, 78 is what you're looking for. So by the time you skip all those numbers, you'll find out that by the time you're getting 78 in base 10, you're already at 116 in base 8. I don't know if you get the concept. If we are counting together, somebody is counting in base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you in base 8, you're only going to count 0, 1, 2, 3, 4, 5, 6, 7. Okay? Then you jump again to 10. You're not going to count 8 and 9. So while that person is counting 8 and 9, you're already in 12. By the time that person is counting 10, you're in 13. You can see that you're ahead of the person already. By the time the person will be counting 28 and 29, you will jump those two. So by the time the person is in 78, you are already in 116. That's the concept. Alright? Because in base 8, you're going to be skipping 2 digits. 8 and 9. 8 and 9. You'll be skipping those digits. So while this person in base 10 is counting all the 9 digits, you'll be only counting 7 digits. Meaning that you'll be ahead of the person. By the time that person is counting 78, you're already counting 116. Alright? But for 5, both of you are counting at the same pace. So while that person is counting in base 10, 0, 1, 2, 3, 4, 5. You that you're counting in base 8, you're also counting at the same pace, 0, 1, 2, 3, 4, 5. That's why they're equivalent. Okay? So you're not ahead of the person by any number, since you are still within the confines of both octal and decimal. I hope that makes sense to you. Alright? Then if we convert base 8, now base 8 is not a digit in octal. I'm sorry, 8 is not a digit in octal. So by the time the person counting in base 10 is at 8, you that are counting in octal, you should have jumped from 7 to 10. Remember, the highest digit in octal is 7. So by the time both of you are counting, you have counted 0, 1, 2. Both of you are counting 0. Both of you count 1. Both of you count 2. Both of you count 3. Both of you count 4. Both of you count 5. Both of you count 6. Both of you count 7. Now you've reached your limit, you that are counting in octal. The other person has not. So the next number you will count, that person counting in base 10 will count 8. But you that are counting in octal, you cannot count 8 because there is no 8 in octal. The highest digit in octal in base 8 is 7. So from 7 you are jumping to 10. 10 is 1 and 0. Both of them are digits in octal. So you are jumping to 10 while that person is counting 8. When the person counts 9, you are counting 11. When the person counts 10, you are counting 13. You see what I mean? So that tells you that 8 in base 10 is going to be 10 in base 8 in octal. But let's confirm it. So 8 in base 10, like I said, from the illustration I gave you, is going to be 10 in base 8. While that person is counting 8 in base 10, you have jumped from 7 to 10. Because you cannot count 8 and 9 if you're working in what? Octal. I hope you get it. I hope you get the concept. It's the same thing if you're working in base 5. By the time you count 0, 1, 2, 3, 4, that's your limit for base 5. I told you the highest digit is always 1 less than that particular base. So if you're working in base 5, your limit is 4. By the time you get to 4, the other person is still counting to 9 in base 10. You will jump from 4 to 10 and start counting 10, 11, 12, 13, 14. That's your limit again. You can't count 15 because there is no 5 in base 5. So from 14 you are jumping to 20. So you can see how you are skipping numbers while that person is counting serially. You will be far ahead of that person. So if we are converting this, just to confirm, 8 divided 8 is 1 remainder 1. Right? And then remember, you must get to 0. 8 cannot divide 1 without it being a fraction, so 0 remainder 1. Sorry, 8 divided 8 is 1 remainder 0. There's no remainder. So if you take this from down, like I told you, 8 in base 10 is 10 in base 8. Okay, so what this shows you now, let me just say it now, because when we start doing addition, subtraction, and other bases in base 10 and other mathematical operations in base 10, you would in number basis, you will need this. Whenever you are converting a number in its own base, the answer is 10. What I mean is 7 in base 7 is 10. 7 to base 7 is 10. 6 to base 6 is 10. 5 to base 5 is 10. 8 to base 8 is 10. 9 to base 9 is 10. 16 to base 16 is 10. So just have that knowledge in your head. When you're converting a number to the same base, if I say you convert 2 to binary, is 10. Okay, so now I've converted the whole number part, I've converted the numerator, I've converted the denominator. So if you bring it together, you have that. Therefore 78 5 over 8 in base 10 will be equal to, now this is the whole number part, 116. The numerator is 5 over denominator is 10 in base 8. This is my answer. I never write it here. 116 5 over 10 in base 8. Okay, so I don't need to write it here. Okay, so this is the equivalent of this number in base 8. 116, just convert the whole number part. 5 is 5 in base 8 and in base 10. Then 8 in base 10 is 10 in base 8. That's it. So I believe if you listen carefully, you should have gotten the concept here. Alright, so whether it's a whole number you have to convert, or a decimal, or a fraction, just apply the same process. Alright, now please do this assignment here. Do this assignment here is to help you be sure that you've understood. They are just two, so do it. And like I always say, you can drop your answer in the comment section or in our community on Telegram or even on YouTube here, or send me a direct message on WhatsApp. Alright, if you found this video helpful, you learned something from it, don't forget to like the video so that other people can watch it as well. Drop your comments, let me know what you liked or loved about this video, and then share it as well to as many people as you can on your WhatsApp status, on Facebook, and everywhere else. Alright, I'll see you soon in another video. In that video, we'll look at how to convert from other bases to base 10, and then other bases, and how to convert between bases. So maybe from base 3 to base 5, from base 4 to base 10 to base 8 or so. Alright, so I'll see you shortly. Please, if you're new here, subscribe to the channel and turn on notifications, ring that notification bell, so that whenever we drop a new video, you will be notified promptly. Alright, thank you for being here. I look forward to seeing you again. Keep learning, keep studying, keep practicing mathematics. The more you learn, the easier it gets for you. Alright, take care. Bye.